All right, students, here's what we got. We're going to talk about inverse functions here. Now, if you were in class all week, you've seen this already, but in case you missed it or in case it just didn't make sense the first time around, oh, that's what I'm here for. Trying to help you out with inverse functions. Okay, so a couple things I want to point out. There's a reason why the title looks kind of funky, and we're going to get to that. You'll notice it has a diagonal line going through the middle, and then these things look like mirror images of each other. That's key. So stare at this for a second. That's what your graphs are going to look like. They're going to look like mirror images like that. Okay, so sort of like they're upside down, but not totally because they're at a diagonal. So, okay, let's jump into it. So, basically what you want to think is imagine you have this bowl of blue dye, and that's your function, and your egg is your input. You input it into the bowl, and it comes out blue. That's what a function does. All right, an inverse function reverses that whole process. So you'll hear me a lot of times call it a reversing function because it reverses the whole process. So our blue egg would go through the inverse function and come out white again. Okay, so let's go backwards a second. Regular function went from white to blue. Inverse function goes from blue to white. All right. Now let's try this with numbers. What you're going to see here, this is your regular function. This is your inverse. And right away, these are easy enough that we can sort of tell that they're related. Squaring and square rooting, those are two opposite operations. So if you square a number, take 3, it comes out as 9. Take 9, plug it in, gives you back 3. That's what an inverse does. That's it. Take 5. Regular function gives you 25. Inverse function gives you back 5 because you started with that. 11. Square it gives you 121. Invert, you get 11. So again, start with any number you want. The function does something to it. The inverse function returns your original number. That's it. Okay, so points-wise, what happens with that is the inputs and outputs end up being switched. So if 4, 7 was one of your points, it would have an inverse point of 7, 4. So we switched the input and output, the x and the y. So -5 and 3, 3 and -5. Let's jump past that. Okay, now here's the key part about this thing. If I give you a graph, or if you're given a graph on the test or on a homework assignment or whatever you're doing, okay, if you have a set of data and you want the inverse of that data, once you have the table of values here, all you need to do is flip-flop it. So, if that's the original, your inverse is flip-flopped. What used to be your outputs are now on your top row. What used to be your inputs are now your outputs. Inputs and outputs have switched. So instead of 0, 1, it's 1, 0. Instead of 1, 2, 2, 1. Instead of 2, 4, 4, 2. So in other words, if you have one table of values, it's not any more work to get the other one, just flip-flop them. Now the effect that creates is this. A line of reflection right down the middle, and this is what it would look like if we connected those with a smooth curve. So this original line, if we connect them, smooth curve like that, and the key idea you need to know, there's your line of reflection. Okay, you got line of reflection right there. Okay, so at this point, now we're going to step into the other thing we need to be able to do with function. If you're given an original function, you want to be able to solve for the inverse. Okay, that's a critical skill. So if you're given an original function, first thing you want to do, you switch the variables. Okay, so literally, you're going to take x and y and switch their physical locations. What doesn't switch is the numbers. None of the numbers go with it, just the x and just the y. All right? Step 2, you're going to solve for y. And that's sort of all dropped out in one quick row here. But basically, try and get y alone. Again, after you switch these two, the rest of the solving, Algebra 1 stuff. One thing I would like to point out, though, this answer, and this answer are technically the same. Okay, so if you're going to split it up, it'd be 1x over 6, or 1/6 x, and then the 12 over 6, which give you 2. Okay, but both of those are the same. Both of those get full credit on a quiz. It's just the back of the book tends to put it one way over the other. So if you do see something different, try and convince yourself they are the same. We're trying to see if you can get them to look the same. All right, one more. Let's go through. Okay, if you have a function like this, okay, first thing you want to do, you want to switch the x and y. All right. Now that we've done that, and notice again, even though it's x squared, only the x switches. The squared, the exponent there, stays. Okay, so even though it's x to the second power, just x comes over here and just y replaces it. All right, and if you solve for y, you can subtract 2 from both sides, so you get that. Divide by 3 on both sides, you get this. And you're almost done, but you still have a y squared, so you would have to square root both sides. And that will leave you with that. And there you go. That's inverse function, folks. Thanks for watching, and good luck on the quiz.